Welcome to Imstat Online. Today we are going to see large samples. Population. A statistical population is a set of all possible measurements and data corresponding to the entire collection of units for which an inference is to be made. Sample a sample is a part of the statistical population. That is, it is a subset which is collected to draw an inference about the population. Sampling distribution the probability distribution of such as statistics called the sampling distribution. Characteristics of a sampling distribution characteristics of a sampling distribution is that if the original population distribution is normal, sampling distribution of the mean will be also normal. Standard error of the mean. The standard deviation of the sampling distribution of mean referred to as the standard error. Of the mean, and is denoted by sigma x. Sigma x equal to sigma by square root of n. Sigma mean. Test of hypothesis. The hypothesis testing addresses the important question of how to choose among alternative propositions while controlling and minimizing the risk of wrong decision. Before going to the hypothesis testing, to understand it more clearly, we want to test the hypothesis that example, he is innocent and take this hypothesis as H naught. H naught, basically there is no significant difference between the mean, small test mean test, general case, then there exists an alternative hypothesis. That is guilty, which we denoted by H1. The analysis of case, the possible types The first two correspondence to the case H0 is true, and the last two correspondence to the case H1 is false or H0 is false. Case 1, the person is innocent, that is H0 is true. For example, the judge finds that he is innocent. That means accept the null hypothesis. Case 2, the person is innocent, that means H0 is true, hypothesis is true, and the judge finds that he is guilty. Reject the null hypothesis. Reject the null hypothesis. Case 3, the person is guilty, hypothesis is false, and the judge finds that he is innocent. Accept the null hypothesis. Case 4, the person is guilty, H0 is false, and the judge finds that he is guilty. So rejects the null hypothesis. In case 1 and 3, the judge takes the correct decision. In case 2 and 4, judge make an error. In case 2, the hypothesis H0 is rejected when it is true, and this type of error is called type 1 error. In case 4, the hypothesis H0 is accepted when it is false. It is called a type 2 error. Type 1 error is considered to be more serious than type 2 error. If we take the null hypothesis as the person is guilty, then type 1 and type 2 error would have been reversed. In general form, accept the null hypothesis, reject the null hypothesis. H0 is true, H0 is false. If accept the null hypothesis, when H0 is true, correct decision. When accept null hypothesis, H0 is for type 2 error. This is type 2 error. Reject the null hypothesis, H0 is true, that is type 1 error. Reject the null hypothesis when H1 is false, correct decision. In statistical hypothesis, test if an hypothesis H0 is rejected when it is true is called type 1 error. And when hypothesis H0 is accepted when it is false, it is called type 2 error. Hypothesis testing procedure. There are two basic types of decision problems that can be considered in hypothesis testing procedure. One, whether a population parameter has changed from or different from a particular value. Second case, whether the sample has come from the population that has a parameter value less than a hypothesis value, or from the population that has a parameter value more than the hypothesis value. In these situations, the attention is focused on the direction of the deviation, either on both sides or only one side. So, two types of tests. One is one-tailed test, another one is two-tailed test. First, we are going to see one-tailed test. The possible set of null hypotheses, possible set of null hypothesis and the alternate hypothesis are: case 1, H0, that is mu equal to mu naught, but H1 mu is greater than mu naught. Case 2, H0 mu equal to mu naught and H1 mu is less than mu naught. That case, H0 mu is greater than or equal to mu naught. The alternative hypothesis, mu is less than mu naught. Then fourth case, the null hypothesis mu is less than or equal to mu naught. The alternative hypothesis, mu is greater than mu naught. But why mu naught? And mu naught is the hypothesis value. In graphical representation, this case, acceptance region (95% of confidence of interval). This one is 0.05 rejection region. Here is set equal to 1.645. Then it's right tiled. That is mu is greater than mu naught. This one. Similarly, the rejection region 0.05, that is it is equal to minus 1.645, that is left-tiled. Mu is less than mu naught. Two-tailed test. The null hypothesis and the alternative hypothesis for two-tailed test H naught mu equal to mu naught and H1 mu is not equal to mu 1. Mu is not equal to mu naught, where mu naught is the hypothesis value. In graphical representation, here this one 95% acceptance region. This is 0.025 rejection region. Here also 0.025 rejection region. Here is it equal to minus 1.96, positive value here is it equal to 1.96. The above consideration of one-tail and two-tail test, we have taken the significant level 0.05. The same way we also consider 0.1 also. In such a situations, one-tail test and two-tail test, the region of acceptance, the region of rejection. This case, suppose 1% level of significance. %, this 1%, here this is 1%, normal distribution 99%, but here is it equal to 2.33, this is it equal to minus 2.33. The above consideration, we assume that the population is normal. If the population is not normal, the sample size should be large, so that the sampling distribution of the test statistics is approximately normal. Large sample test. Large sample test. First, test for a specified mean. Specified mean. Second case, test for the equality of two mean. The third case, test for specified proportions. Fourth case, test for the equality of two proportions. Test for a specified mean, a random sample of size n is drawn from the population. We want to test the population mean has a specified value of mu naught. And inferences for a significance level alpha equal to 0.05, that is 5% level of significance. If modulus of Z is less than 1.96, then H naught is accepted at 5% level. If modulus of Z is greater than 1.96, H naught is rejected at 5% level. Suppose for alpha is 0.01, that means 1% level of significance. If modulus of Z is less than 2.58, the null hypothesis is accepted at 1% level. If modulus of Z is greater than 2.58, the null hypothesis is rejected at 1% level of significance. Procedure for one-tiled test. Left tile, H naught mu is greater than or equal to mu naught, H1 mu is less than mu naught. Left tile at alpha equal to 0.05, 5% level of significance. The critical value of modulus of Z equal to 1.645. If Z is less than minus 1.645, H naught is rejected. If Z is greater than minus 1.645, H naught is accepted at alpha equal to 0.01. The critical value Z is 2.33. One tile right tile. If Z is less than 1.645, H naught is accepted. If Z is greater than 1.645, H naught is rejected.